MCP Model Context Protocol, a beginner's guide for data and GenAI engineer. Do I need MCP if I already used RAG? Can I keep using LangChain LlamaIndex? What about cost, latency? How MCP differs from plugins or framework specific tools? I will cover I will cover all these questions in this video. So let's start. Large language models are trained in fixed snapshot of data, so they don't automatically know what's in your live database. Logs are SaaS tools, meaning this answer can be outdated. The bridge that gap, teams keep building the same glue over and over. SDK wrappers, custom API, RAG pipeline, and connectors to storage are such. Let lots of duplicated work. That's hard to maintain. On top of that, writing a model directly to your system raises security risk. You might end up sharing database credentials, broad file system access, or sensitive documents, which increases the blast radius. If anything goes wrong, in short, LLMs need fresh context, but getting it safely and without reinventing the wheel is the real engineering challenge. The Model Context Protocol is an open, standardized framework that governs how artificial intelligence system, particularly large language model, securely connects and interact with external data sources, tools and services. At its core, MCP provides a universal language or handshake that allows an AI to move beyond its static, pre-trained knowledge and engage dynamically with the digital world. A powerful analogy for understanding MCP is to think of it as the USB-C port of AI. Before the advent of universal connector like USB-C, every electronic device, phones, camera, laptop, had its own proprietary charger and data cable. This created a where users needed a different adapters for every device. USB-C solved this by creating a single universal standard that works for everything. MCP aims to do for AI what USB-C did for hardware. It establishes a standardized way for any AI model to connect to any external tool or data source, eliminating the need of developers to build countless custom one-off adapters in the form of bespoke application programming interface API integration. Here is a simple mental model for MCP. Client. The client is where you talk to model, your app's chat window, a CLI, or ID assistant. That separation matters because it keeps the user's interface independent from backend capabilities. So you can swap models or add skills without redesigning the UI. For instance, a VS Code assistant that answers question is a client. From there, it needs a way to reach real data and actions, which leads us to server. And MCP server is the thing that exposes your organization capabilities in standard, safe way. This standardized is a valuable because it prevents one of glue code and keeps credentials and policies on the server side. Imagine running a Postgres server for analytics, a file system server for PDF, and web fetch server live pages all at once. Each server advertises what it can offer, and those offers show up the client as a resources, tools, and prompts. Resources. Resources are read-only data the model can browse or fetch. Read-only is important evidence of safety. The model can learn from the information without changing anything. Think policy PDFs. Tables like order last 90 days, a URL or a vector index, a support bot, for example, can open the holiday return policy PDF resources to ground its answer. When you need to do something rather than just read something, you move from resources to tools. Tools are action with clear JSON schema, inputs and outputs, which is what makes them reliable and auditable. The schema is guardrail. It tells the model exactly what fields to send and what shapes to expect back, preventing sloppy or dangerous calls. A few practical tools might be run SQL, search web, send email, behind approvals. Tools get you consistent, safe execution, but you also want consistent, high quality instruction, which is where prompts help. Prompts are named reusable templates the model can request and fill. so your instructions stay consistent across teams and sessions. This improves quality and reduces prompt drips. For example, a safe SQL generation prompt can always remind the model to parameterize queries and respect a read-only schema, or a support answer. Prompt can enforce tone, citation format, and refusal rules. With prompt standardizing instruction, tools executing actions, and resources grounding facts. The client and server together form a clean loop, and model can use the work safety and effect. You grant least privilege access by choosing which server to run and what they exposes. You want the model to answer business questions like weekly failed payments directly from Postgres without ever sharing database credential dumping CSV or risking destructive. You stand up a lightweight Postgres MCP server that exposes only what's safe, a schema resource, read only run SQL tool with this JSON schema, a view resources, and allow less restrict access to public schema and caps row counts to avoid data exfiltration or runway scan. Example, at runtime you ask, so last 7 days failed payments per gateway. The client, the chat ID, lets the model browse resources first. So it opens DB to discover relevant tables and columns. With that context, it generates a shape, parameterize SQL and calls to run SQL tool. The server executes the query under read only, limit enforce guardrail and returns rows. The model then summarizes the result, optionally calls a render chart, tools to visualize them, and replies with a short narrative, the SQL it run, and bar chart. Throughout, no credentials are exposed and every action is constrained, logged, and reproducible. Example at runtime you ask. So last 7 days, failed payments per gateway. The client lets the model browse resources first. It's OpenDB to discover relevant tables and columns. With that context, it generates a safe parameterized SQL and calls the run SQL tool. The server executes a query under read only, limit enforced guardrail, and return rows. The model then summarizes the results. Optionally, call a render chart tool to visualize them and replies with a short narrative, the SQL it ran, and bar chart. Throughout, no credentials are exposed, and every action is constrained, logged, and reproducible. This pattern is scale, so appose Snowflake or BigQuery. Plugin caching or approval or add tools like export CSV and schedule report. MCPs is split between resources, read-only facts, and tools control actions. Gives you auditable safety by default while still delivering fast self-server BI answer to your team. You want a support bot that stays up to date, cites its resources, and can actually do things like start a return. Instead of only chatting, classic LLMs go stale and guess. You need agentic RAG so the model can retrieve fresh facts and take safe action. Set up three MCP server once, a file system server, a fetch server, and a vector server with standard tools. Embed, vector, index, and search. MCP gives you JSON schema, input output, allow list, logs, and clean split between read-only resources, and tightly scope tools, so everything is auditable and safe. A user asks, what's the holiday return window for shoes? The agent first plans. If the index looks stale, it reindexes the newest files from the database using tools. Index then it runs tools search with the query, picks the top passes, and generates an answer grounded in these snippets with inline citation to exact docs. If it sees ambiguity, it asks a clarify question before finalizing. If allowed, it can also act, call create return label to help the customer complete the task. This agentic RAG pattern generalizes swap the knowledge base, adds tool for tickets, or plug-in analytics. Your client stays simple while MCP standardized retrieve and actions. The result is trustworthy bot that's current, cite sources and safety does things, not just talk. How MCP is different from plugins or framework specific to standard, not a product feature. MCP is a protocol app client and any services server can speak. If both sides implement MCP, they interpolate, no vendor lock-in. Your internal chat assistant can talk to Python file server you wrote, a Postgres server you data from your own, and web-based server from another team. This lets you reuse the same tools across ID assistant, chatbots, and patch jobs without rewriting integration. Strong typing via JSON schema. Ever tool resource and prompt has explicit input-output schema. The client can validate argument before calling tools. The server can reject malformed inputs. Security first boundaries. Server define exactly what's exposed. Client can sandbox calls. You can allow list, schema path, enforce read only, set row caps, and redact secrets in logs. A DB server that only exposes public, only allows select, and automatically applies limit 1000. You stop giving models raw credential or blanket file system access composable with your favorite stacks. MCP does not replaces LangChain LlamaIndex. It wraps them or vice versa. Turn a LangChain pipeline into a single MCP tool or let your agent use MCP server as its data layer. An MCP vector server that internally use Fies Chroma plus a web server that uses Playwright. Both appears standard tools to any client. You keep your existing libraries while gaining a common contract. Common FAQ for engineers. Do I need MCP if I already use RAG? RAG a pattern. MCP the protocol makes your data sources and action portable across clients. Use them together. Can I keep using LlamaIndex and LangChain? Yes, wrap your existing pipeline as an MCP server so any MCP clients can call it. What about cost latency? You can decide when a call tools versus answer from context. MCP doesn't force calls. It just makes them a standard and one page cheat sheet. MCP standard way for models to see data and do work, resources, things to read, tools, functions to call, prompt reusable templates. Perfect for data engineer, say SQL BI answer, and GenAI engineer, agentic RAG, action taking bots. Less glue code, safer access, portable integration, faster iteration. Thank you so much.